We're going to review the math practice from today to make sure that you have no questions before it's time for you to take your final exam on Friday. You need to make sure that you understand how to do all of these problems, so you can fast forward to the parts of the video that you think you need, or if you think you need the whole thing, you're more than welcome to watch the whole video. We're going to start with the circle on the first slide. So on this slide, we notice that we have a circle, and this measurement that goes from the midpoint to the edge is 3 feet. Well, we know that this, if we go from one edge to the middle of the circle, is the radius. So the measure of the radius of this circle is 3 feet. The diameter would be the measure that would go from the edge of the circle all the way through the midpoint and to the other edge of the circle. So the diameter would be twice the radius. So to get the diameter, I would do 3 times 2, which would give me 6 feet. Now to find the circumference, I'm going to have to use the formula for circumference. And that formula is circumference equals pi times diameter. Well, I'm going to use 3.14 for pi, and then I'm going to multiply it by the diameter. I already found that the diameter was 6, so I'm doing 3.14 times 6. And when I do 3.14 times 6, I get 18.84. So the circumference of this circle is 18 and 8400 feet. Now I'm also going to need to find the area of the circle. So to find area, I have to use the formula area equals pi times radius squared. Again, I'm still using 3.14 for pi, but for this formula, I need the radius. I know that the radius of this circle was 3, so it's times 3 to the second power. Then I just need to solve. I need to do my exponent first, so I would do 3 to the second power. And I remember that 3 to the second power, it doesn't mean 3 times 2, it actually means 3 times itself 2 times. So it means 3 times 3, which is 9. So now I'm going to do 3.14 times 9. Now all I have to do is multiply 3.14 times 9. And when I do that, I get 28.26. And I have to remember that because it's an area, it's square units. So I would measure this in feet squared. Now, if you're typing that and you can't type an exponent, you can always write square feet. Now for our next slide, we're going to look at what side measures make triangles and what side measures do not make triangles. If I remember my triangle inequality theorem, it says that if I take my 2 shortest side lengths and add them together, they should be greater than my third side length. So whenever I'm doing this, I always need to start with my 2 shortest side lengths. In this case, it's 4 and 5. So because they are my 2 shortest, I know that if I add them together, they should be greater than my third side length. And the third side length on this triangle is 8. Now I'm just going to solve. 4 plus 5 gives me 9. And then I ask myself, is it true that 9 is greater than 8? Well, yes, that is true. So because it's true, I know that 4, 8, and 5 do create a triangle. Now I'm going to look at my next one, which is 6, 2, and 4. In this case, my 2 shortest side lengths are 2 and 4. So I'm going to do 2 plus 4, and those should be greater than my third side length, which is 6. Well, when I add 2 plus 4, I get 6. And so now I ask myself, is it true that 6 is greater than 6? Well, it's actually not true because 6 is equal to 6. So because 6 is not greater than 6, this does not make a triangle. Now let's look at our next one. We have 7, 5, and 3. Our 2 shortest sides are 5 and 3. So I would add those together. And if this is a triangle, they are going to be greater than my third side, which is 7. Well, when I add 5 plus 3, I get 8. And now I ask myself, is this true? Is it true that 8 is greater than 7? And yes, it is. So because of that, I know that these side lengths create a triangle. Now let's look at 12, 4, and 15. In this problem, my two shortest side lengths are 12 and 4, so I'm going to add those together. And if this is a triangle, then those should be greater than my third side, which is 15. Well, if I do 12 plus 4, I get 16. And now I ask myself, is 16 greater than 15? Well, yes, 16 is greater than 15, so that means that these also create a triangle. And now let's look at our last one. So for this one, I have 8, 5, and 10. My two shortest side lengths are 8 and 5, so I'm going to add those together. And if they make a triangle, then they are going to be greater than my third side, which is 10. Now I'm going to add 8 plus 5 gives me 13, and then I ask myself, is 13 greater than 10? Well, yes, 13 is greater than 10, so that means these side lengths also create a triangle. So for this problem, the only one that did not create a triangle was 6, 2, and 4. For this problem, we're going to figure out what the measurements are for each angle. So we're going to find x, y, and z. Now to do this, we need to know things about supplementary and vertical angles. When I look at this, I know that x is opposite of 62. Because they're opposite of each other, we know that they are vertical angles. So that means that the value of x is going to be 62 because all vertical angles are congruent. Now, I also need to figure out what y equals. So if I look at this, I know that they are on this straight line, and every straight line has a value of 180. Well, I know that these two angles make up the straight line, which means that together, these two angles would equal 180. So to figure out what y equals, I would do 180 minus 62. And if I do 180 minus 62, I get 118. That means that the value of y is going to be 118 degrees. Now, I can use that to find the value of z, because if I look at my angles, I know that y is opposite of z, so these are vertical angles. And since all vertical angles are congruent, since I know that y is 118, I also know that z is 118. Now we're going to look at some exponent problems. In this first one, we notice that we are multiplying my exponents, which means we're going to be using the product rule. When we're using the product rule with exponents, that means that we are going to be adding the exponents. What I'm going to do is I'm going to start with every base. So my 4s, when I have a base of 4, I have an exponent of 2, and then I'm multiplying that by 4 with an exponent of 3. Because these have the same base and I'm multiplying, I'm just going to add my exponents. So I'll add 2 plus 3, and that's going to give me an exponent of 5 here. Now I'm going to do the same thing with a. This a has an exponent of 4, and this a has an exponent of 2. So a to the 4th times a to the 2nd, I'm going to take my exponent of 4 and my exponent of 2 and add, and that gives me a to the 6th. Now I'm going to do the same thing with b. So for b, I have b to the 3rd times b to the 5th. So I take my exponent of 3 and exponent of 5 and add. So 3 plus 5 gives me 8. So this becomes b to the 8th. Now on this problem, because I noticed that if there's a fraction bar, that actually means that I'm going to be dividing these problems. Well, whenever I'm dividing and I have the same base, that means that I need to subtract my exponents. So when I look at 12 to the 15th divided by 12 to the 5th, I'm going to do 15 minus 5, which gives me 10. So this becomes 12 to the 10th. Well, if that worked. So this will be 12 to the 10th. And now we're going to look at our x. So for x, I have x to the 9th over x to the 6th. Well, I'm going to do 9 minus 6, which gives me x to the third. And finally, for y, I'm going to do y to the 12th divided by y to the 4th. So I'll do 12 minus 4, which gives me 8. So this becomes 12 to the 10th, x to the 3rd, y to the 8th. For our last slide, we're going to be solving these exponent problems. So our first one says negative 7 to the second power. For this problem, because the negative is not in parentheses, the only thing that's being raised to the second power is 2. So this problem is really saying what is the opposite of 7 to the second power. So I would need to find 7 to the second power. And some of you were getting confused on this part and you were putting 14, but you need to remember that 7 to the second power actually means 7 times 7. And when we do 7 times 7, we get 49. But this negative sign out here tells me what is the opposite of 49. And the opposite of 49 is negative 49. So for this problem, our answer should be negative 49. For negative 9 to the second power, this negative 9 is in parentheses, so that means that I'm doing negative 9 to the second power. And negative 9 to the second power means negative 9 times negative 9. Well, I know that a negative times a negative is a positive, and 9 times 9 is 81. So this answer is going to be positive 81. Next, I'm going to do negative 4 to the second power. Again, for this problem, I noticed that I do not have a parentheses. That means that the second power is actually on my 4. So this is telling me to find the opposite of 4 to the second power, which means I need to find 4 to the second power first. 4 to the second power means 4 times 4, and 4 times 4 equals 16. Now, I need to remember that this negative sign means I need to tell the opposite of that. So the opposite of 16 is negative 16. And finally, I have negative 2 to the second power. So for this problem, I have negative 2 inside parentheses, so that means I'm raising negative 2 to the second power. And that means I'm multiplying negative 2 times itself twice. So I'm going to do negative 2 times negative 2, and a negative times a negative gives me a positive. And then I'm doing 2 times 2, which gives me positive 4.